Hey, hi everyone. So, welcome again. And let's discuss the equation of planes in space, no? In three dimensions or R cube. So, given again, we have the given reference point R sub 0, which is, we know that we represent this as X sub 0, Y sub 0, Z sub 0, or to be specific, a vector. And let's say we have a new variable here, N, which is actually a vector as well, which is represented in a similar manner as a vector v in the previous topic, and then r is still xyz, then we can represent the equation of a plane as, so if you can remember, we can just draw, let's say, an arbitrary plane. So let's say this is your space. Okay, let's just imagine we have this 3D space, and let's say, let's try to create an arbitrary plane. So this plane now, we can imagine we have this infinite sheet extending to all directions. Okay, but I will just erase this for now. I will erase this as well. So we can pick any arbitrary point here that could be represented as a point. Again, now we have this point. We have, let's say, x, y, z. And then let's say we have another reference point. Let's say this is p sub 0, which has a coordinate of x sub 0, y sub 0, and z sub 0. Okay, so we could represent these 2 points as a vector. Again, no, in another way. So we have this r sub 0 vector, and then we have another point here, which is this r vector. And then, how do we represent this plane? So in a plane, we have an important property of a plane is that it has this orthogonal vector at any point. So the orthogonal vector is always the same for every point in the plane. So let's just pick this one, and let's draw here an arbitrary vector, and let's call this vector n, which is perpendicular to our plane. Okay, so we have this n vector. And then what could we see here now? So we could create a relationship between these three vectors. As we can see, we can find the difference between these two vectors. We have r vector minus r sub 0 vector. Let me just draw this first pala, no? So let's say this is r0 vector and this is your r vector. So to create this third vector, we actually have the difference between these two vectors. Okay, this is the triangle law. Although, no, this is not addition since this is a different, no? You can see here now, this is different. Or another way to look at this is we have r sub 0 plus this one is equal to this. Okay, so r sub 0 plus r minus r is equal to r, no? So because this will cancel out, no, using the triangle law. So what is the significance of this? Why do we need to find this? So because this vector r minus r sub 0 is perpendicular or orthogonal to the vector n, which is a property of a plane wherein this n is always, there is also an n here, no? A property of this plane is that we have an orthogonal vector n at any point. So creating this relationship, we can say, no, we know that this is 90 degrees. So therefore, drawing this again, this n vector is orthogonal to this r minus r sub 0. Therefore, their dot product, if you can remember, the dot product of these two vectors should be equal to 0. Ano? So there goes our first equation or our first relationship to represent the plane. And then we can simplify this, no? We can distribute this n using the property or the theorem of dot products. We have n dot product of r minus n dot product of r sub 0. And then transposing this to the other side, you have n r is equal to n r sub 0. So that product of this two. So we have another equation to represent plane. And then something more significant so that we have a real equation, not just a relationship of vectors. We can substitute this n and then r sub 0. So we know that n, we can represent this as ABC, we have r sub 0, we represent this as x sub 0, y sub 0, z sub 0, and then r as x, y, z. Then therefore, we could write this as, so n is equal to a, b, and c. Okay, this is for n, and then for r, we have r. This is x, y, and z. And then equals to the dot product of n again, so a, b, c. And then dot product of r sub 0, which is x sub 0, and then y sub 0, z sub 0, close this vector. Okay, sorry. Yeah. Okay, so when performing that product, how do we do this? We multiply this entry-wise and then add their products. So we have ax plus by and then plus cz. And then equals to, we have ax sub 0 plus by sub 0 plus we have z sub 0. So if we transpose this, no, everything here to the other side, we will have ax plus by plus cz minus ax sub 0 plus, minus by sub 0 minus cz sub 0 is equal to 0. And then grouping this, we can see that we have a, no? Okay, we have a times x minus x sub 0, right? And then you have b times y minus y sub 0, and then plus c, and then we have c, we have z minus z sub 0 is equal to 0. Okay, so this will be another way to represent your plane. Okay, so again, no, we have another cleaner way to show this. Okay, so we have this equations, and to add to this, if we simplify this, or if we distribute these values here, we will have a new constant. Let's call this letter d. So this will be important later. Just remember that we can distribute this, no, and then we will have a constant, no, that represents this d. Okay. So an example here, find an equation of a plane through the point 2, 4, -1 with normal vector n, 2, 3, 4, find intercepts, and sketch the plane. Okay, so find an equation given this point and this vector. So what is this? So this is your p sub 0. Oh? So we have an initial point or a reference point, and then we have already our n vector. So yung p sub 0 natin, we could write this as r sub 0, which is, or this r sub 0 vector, which is 2, 4, and 1, or -1. And then this is basically your x sub 0, y sub 0, and z sub 0. And then for this one, we have this orthogonal vector, and the way we represent this is we have a and b and c. Remember. So how do we find the equation of a plane? So the thing to do here, the easiest way, the most direct way is we have this equation. We have a times x minus x sub 0 plus b times y minus y sub 0, and then plus c times z minus z sub 0 is equal to 0. So we can just substitute this directly since we have this given as a given. Okay, so we have a, so 2 times x minus 2, okay, so 2 and 2, plus b, so b here is 3, so 3, and then y minus, so y sub 0 is 4, and so on. So 4, and then z, so -1 will become positive, so minus -1, this will be positive 1, is equal to 0, and then we can just simplify this. Actually, you can just box this one. But to make things better, we can just distribute this. So we have 2x, and then, sige, let's add this later, no? We have 2x plus 3y plus 4z, and then we have -4, so this one and this, and then we have -12, and then 4. Okay, so to simplify this, we can cancel this 2, So we have 2x plus 3y plus 4z minus 12 is equal to 0. So we can just box this as it is. Okay, or you can also write this in the other side of the equation if we want to. So we want to find intercepts and we want to also sketch the plane. So how do we do that? No? So what are intercepts? So if you can imagine, we have this three-dimensional space. Again, three-dimensional space. This is too long, no? Yeah. Okay. So the intercepts here are when does the plane intercept this x, y, and z axis. So what can we see here? No? Or what can we say here? When will it intercept this x? No? So it will intercept this x. No? So we will have an intercept here if z is equal to 0. No? So x-intercept, okay, is when z is equal to 0, if you can see, and also y is equal to 0, right? That diba? So we can just substitute this z is equal to 0 and y is equal to 0. No? So if you can imagine, the height here is 0, so this z is equal to 0. So since this is 0, okay, so this is positive z, this is negative z, and then this will be 0 in y as well. So this is negative y, this is positive y. So that is why that is the x-intercept. So that will be true as well for the y-intercept. This will be z is equal to 0, and then x is equal to 0. And then for the z-intercept, we have x is equal to 0, and then y is equal to 0. So for the x-intercept, let's solve for the x-intercept first. Okay, so this will be 2x, sorry, yes. We substitute 0 to y and z. So this will be 2x minus 12 is equal to 0. Therefore, x is equal to, so we have 12 over 2. So this will be 6. Okay. So we have here a coordinate 0, no? Sorry, 6, no? So we have x, y, z, so 6, and then 0, and then 0. For the y-intercept, let's say this is your y-intercept. So we have, okay, so for the y-intercept, let's say this is your y-intercept. We have uh, uh, z is equal to 0 and x is equal to 0. So this we will make this 0. So we only have 3y minus 12 is equal to 0. Therefore, x is equal to, so 12, and then divided by 3. So we have 4. Oh, sorry, this should be y, you know. So this will be 0. Okay. So we have 0, and then we have 4, and then we have 0. Okay, for the z-intercept, okay, we have to make y and x 0. So we only have 4z minus 12 is equal to 0. Therefore, z is, so we have 12, positive 12 over 4. So this will be 3. So this will be your coordinate. So x is equal to 0, y is equal to 0, z is equal to 3. Therefore, if this is your intercepts, we can form here a plane. No? You can imagine a plane here that forms this triangle, and then we can extend this infinitely through all directions, no? Even here. So if you extend this, this is your surface area of your plane. Okay? So that is the sketch of a plane and their intercepts. Okay, so remember this one. Okay, another problem here. So find an equation of a plane that passes through the points P, Q, and R. Okay, so let's draw this first to have an idea. What does this even mean, no? Or what is the problem trying to find? Okay. Okay, so let's just have this. Where's that? Let's show slideshow. Yeah. Okay, sorry, it did not update. Okay, so let's move on. So let's say this is your P. Okay, I know how to draw this already, you know. So sorry. So this is your P. we have 1, 3, 2, and then we have a Q here. So this is Q, which is 3, -1, and 6. And then we have this R here, which is 5, 2, and 0. So given these 3 points, we can find this plane. So you can imagine, we can draw a plane here that is this sheet and then extends through all directions. So I will erase this for now. And then we can figure out a way to find this by how, no? So what we can do here, guys, is we can create a vector that passes through this P and Q and then also this P and R. So we can call this the vector uh, PQ, okay? And then this vector PR. So why did we do this? So that we can create here a vector that is orthogonal to our plane. So you can imagine again, our plane here is this. So this plane here is orthogonal to this vector, which is the cross product, if you can remember, no? So PQ, the cross product of PQ and PR are orthogonal to this. Okay? So to find this n, no, which is essential for finding the plane, the equation of the plane, we want to find the cross product. And how do we actually find also the PQ and PR vectors? So to find for the PQ vector, okay, so we want to find the difference between these 2 points. Actually, you have to write this 3. So 3 first, no? So since Q is a second, we have the formula. We want to make the right-hand side, no, of this vector as the positive one. So we have here 3 minus 1. So this is your 3 and 1. And then we have -1 and 3. So -1 minus 3. And then 6 minus 2. Okay. So PQ vector is equal to 2, -4, and 4. Okay. For the vector PR, we have here, so this is 5 and 1. So 5 minus 1, 2 minus 3, and then 0 minus 2. So this is equal to 4, and then -1, and -2. So we want to find the cross product of these two vectors, PR and PQ. It should be PQ and PR. Actually, it could be PR and PQ or PQ and PR. No, it depends on what you want. But I'll just make this PQ and PR. So this will be similar to what I did last time. Okay, so this will be finding the determinant of this 3 by 3 matrix, wherein your PQ is your first matrix here, or sorry, second row here. And then this one will be your third row. Okay, so how do we find the determinant? So there's a technique that I learned from you guys. What we can do here is we can first extend this first two columns, and then J for, sorry, -4 and -1. So for the I, we can just multiply this three terms here. So we have +6, no? So, sorry, +8, right? So we have 8i, diba? And then plus, sorry, minus this one. So we have here -4 for I. Okay, so this is one thing I learned from you guys actually. And then for the J, we have plus. So 4 times 4 is 16. So 16J minus, so this J here. So we have -4J. And then for the Z term, what do we have here? So for the Z term, we have the K. So this one, we have -2K minus, so the K here, minus -16K. So the cross product of this will be 12I hat plus 20J hat And then this will be, so this will be positive 16 minus 2. So plus 14k hat. So this will be your orthogonal vector PQ, which is actually also equal to the n vector. So we can just call this the n vector with regards to our plane. So how do we find this vector or this equation of a plane? Okay, so we have the formula. We have a x minus x sub 0 plus b y minus y sub 0 and then plus c times z minus z sub 0 is equal to 0. So what are the a values, no? A, b, and c values here. This is actually your a, your b, and your c. So we have 12, okay? And then what about the x sub 0? So actually, guys, you can pick any of these three. It will be the same, no? It will be equivalent. But to make things consistent, I will just make use of p here. So we will substitute here. So the x sub 0 is 1. And then this will be your y sub 0. And this will be your z sub 0. So we have x minus 1 plus, so b here is 20. Okay, this one. So y minus 3 plus, we have 14. Z minus 2. And then equals to 0. Okay, actually you can just box this one, but you have to simplify this, no? So we have 12x, okay, this will be this. Let's solve this later, you know, the constants. So we have plus 20y and then plus 14z. And then let's multiply the constants here. So minus 12, minus 60, minus, what is this? 28. Okay, so let's add this. So we have, what is this? 2. We have 40, so negative 40, and then minus 60, so 100. So 12x plus 20y plus 14z minus 100 is equal to 0. Okay? So, can we simplify this? We can actually simplify this. No? We can divide this by, so this is divisible by 2. So 12 is divisible by 2, divisible by 2, divisible by 2, divisible by 2. So we can divide this by 2 so that the final answer will be the lowest form or the simplest form. So we have 6x plus 10y plus 7z minus 50 is equal to 0. So this will be your final answer in simplest form. Simplest form. Okay. So find the line at which uh uh at which where is it? At which the line with the parametric equations uh intersects the plane 4x plus 5y minus 2z is equal to 18. So how do we do this now? No? So we have already the parametric equations given and the plane given. So we want to find the intersection. So how do we find the intersection of a given plane and a line? So we can imagine this as this. Let's say this is the plane, and then we have this line. So there will be some intersection somewhere here, which will be your intersection of. I don't have a notation for intersection. So how do we find this intersection? The intersection is when the x and y and z values are equal. So therefore, what we can do here is we can substitute the parametric equations to each of these variables, x, y, and z. So this will be expanded into, so we can substitute this x into here, this y into here, and then the z is equal to here. So we have here 2 plus 3t plus 5, and then y, y is equal to negative 4t, and then minus 2, and then z is 5 plus t is equal to 18. So simplify this, we have 8. Okay, so 8, I guess I will just add every constant first to make things easier, you know. So we have 8 and negative 10, and then the one with the variable. So we have plus 12t minus 20t, and then minus 2t is equal to 18. So this will be negative 2. This will be, this is negative 8, negative 8t, and then minus 2t. So this will be negative 10t is equal to 18. Therefore, distributing this to the other side, you have negative 10t is equal to, so plus 2, ano? So this will become positive, so 20. So therefore, t is equal to, so divide this by negative 10, we have negative 2 as our t. So what does this mean? So is this your final answer? So not yet, no? So this is just the parametric variable that when we substitute here will yield us the coordinates x, y, and z. So we will substitute this t is equal to negative 2 to get this intersection. So for x, we have 2 plus 3 times negative 2. So this will be equal to, I guess this will be equal to, so negative 6 plus 2, so negative 4. Okay. And then for y, we have a negative 4 times t. So negative 2 here, this will be positive 8. Okay. And then for your z, you have 5 plus negative 2. Negative 2, that is equal to 3. So therefore, the point of intersection, we have the point of intersection that is negative 4, 8, and 3. So you can write this in this form or in this form. Okay, so an important thing about planes is that we can determine if they are parallel with regards to their normal or their orthogonal vectors. Normal vectors or their orthogonal vectors. So if their orthogonal vectors are parallel, then these two planes are also parallel. So we can imagine, let's say we have a plane here on top, and then we have another plane here below. So we can see, let's say this is your vector for this first plane and then this other plane. So if we can extend this, no, and we can see that they are parallel, therefore, if the orthogonal vectors are parallel, then their planes are also parallel. Okay, that is one way to visualize this one. So therefore, we can say that the vectors or the orthogonal vector of the first plane cross product by the orthogonal vector of this other vector, that is equal to 0. So if you can remember this in your properties of dot product and cross product, so the cross product of two vectors, when it is equal to 0, then they are parallel. Okay, so let's solve this one. So find the angle between the planes xyz is equal to 1, x minus 2y plus 3z is equal to 1. Okay, so how do we do this? So how do we find the angles? So based on what is visualized here before, guys, no? So this angle here, this angle in between these two orthogonal vectors is also the same as the angle between these two planes. So I will show you the proof, no, geometric proof, but we already know that this is the case, no? So to find this angle, we want to find orthogonal vectors of these two planes. So how do we find orthogonal vectors of these two planes? Okay, so what is the general form of a plane? So we have ax plus by plus cz plus b is equal to 0. You can remember. So we have a, b, and c. What is a, b, and c? So actually, the orthogonal vector is also this a, b, and c. So we can already know actually that this first plane has an orthogonal vector. Okay, the coefficients of this x, y, z are 1. So 1, 1, and 1. And then for the other plane, the coefficients of that are, we have 1, negative 2, and positive 3. So we have already the two given vectors. So to find the angle in between, we have the topic in the dot product topic. No? So cosine theta is equal to the dot product of these two vectors over the length of these two vectors. Okay, so simplify this. Okay, we have this n vector. We want to find the dot product, these two vectors. So we want to multiply this entry-wise and then sum this products. So we have 1 times 1 plus we have 1 times -2 and then plus 1 times 3. Okay, that is for the numerator. For the denominator, we want to find the length of these two vectors. So how do we find the length of a vector? We just square, no? Or we find the square root of the sum of this squares. So we have sum of these squares. So 1 squared, 1 squared, 1 squared. And then multiply this by, again, the length of this second orthogonal vector, which is the square root of the sum of the squares again. No? So plus -2 squared plus 3 squared, or 3 squared. So simplifying this, we have that, we know that cosine theta is equal to, so this is equal to 1 minus 2 plus 3. So 1 minus 2 plus 3. So we have 2, no? So 2 over, so what is this? So we have square root of 3. This is, so multiplied by, what is this? So this is the square root of 1 plus 4 plus 9. So we have 14, right? So how do we solve this? So the square root of 13, sorry, square root of 3 times the square root of 14 is also the same as square root of 3 times 14. So this is also equal to, so 3 times 14, we have 2, so 42. So this is equal to 2 over square root of 42. So this is already an answer for me now, since we are not using the calculators. But if you want to find the angle, if the calculator is allowed, you can find inverse cosine, okay, which is approximately equal to 72 degrees. Okay, you can find that out. Okay, so until this point lang, when we do not have a calculator, okay? Okay, so find the symmetric equations for the line of the intersection L of these two planes, x plus y plus z is equal to 1, and x minus 2y uh, plus 3z is equal to 1. I'm sorry. Okay, so how do we do this? So we have two planes. Now, can you imagine, let's say we have two planes. Now, I won't draw this exactly, you know. Let's just imagine two planes. So this is the first plane. And then let's say we have another plane. Yeah. Okay, so they have some intersection. So I did not draw this perfectly enough. So as you can see, these two planes has an intersection, which is a line. No? So this line L is what we are trying to find. The symmetric equations of this line L is what we are trying to find. So how do we do that? Okay, so how do we find this line L? Okay, so we can choose any value first. So to describe a line, if you can remember, we need an initial point, which is your r sub 0, and then we should know also the direction, this v. So for the initial point, we can choose any arbitrary point in here, right? So we can assume any point here as long as their values are the same. So we can assume, no, we can assume, okay, I think here, we can assume, okay, we can assume here that when z is equal to 0, we can find an equation that solves for x and y here. So to simplify this, we have x plus y, and then make this 0, so is equal to 1. And then also for this equation, so z is equal to 0, we have x minus 2y is equal to 1. So one thing we can do here is to add these two equations to solve for x and y. So we can add or subtract these two equations. So what will I do here? I can subtract these two equations so that x minus x is equal to 0. And then y minus -2y will be, so y minus 2y is y plus 2y. So this will be plus 3y. and then 1 minus 1 is equal to 0. So we can see that y, to divide this by 3, so y is equal to 0. So solving this again, now we can substitute this either to first equation or the second equation to solve for x. So we have x plus 0 using this first equation is equal to 1. So x is equal to 1. So therefore, we can say that one of the points we can say that the arbitrary point p sub 0 that is equal to so 1 no x muna ano so x, y, and z. So this will be equal to sub 0 pala to no. So we have 1 and then we have 0 and then 0 for another arbitrary point in this line. For any other arbitrary point no that we can pick. And what's next here? So what we want to do is find this orthogonal vectors. Actually, we already solved this. This is the previous problem, right? Okay, we already solved for this, no? So this is also the previous problem. So we want to find this orthogonal vectors. This is the first orthogonal vector and this other orthogonal vector. And if you could imagine, let's say this is your orthogonal vector. Let's say this is n1. And then let's say this is n2. Then an orthogonal vector of these two vectors, okay, will be this dot product. So as you can see here, this also points in the direction of this line L. So we can find this cross product of these two orthogonal vectors to actually find this v vector, which is the direction of your vector. So for this orthogonal or for the dot product of these two vectors, we should solve this first to find this vector v. Okay, so we already solved or we already shown this one last time. So we have 1, 1, 1, and 1, negative 2, 3. So we have 1, 1, 1, 1, negative 2, and 3. That's right. And then we have I, J, and K. So finding the determinant of this 3 by 3 matrix to find the cross product, we can replicate or we can duplicate this first two columns. So we have I, 1, 1, J, 1, and negative 2. So a technique. Okay, so we multiply this for I. So we have 3I, and then for this one, so minus negative 2I, okay, plus we have J, so J here. So plus we have J, okay, minus J here. So minus 3J. And then for the K, so plus we have negative 2K. And then the K here. So minus K. And then simplify. So we have 5I. And then we have negative 2J. And then minus 3K. Okay. So this will be your orthogonal vectors dot product. Now this is also, again, we know that this is also your directional vector. As you can see, this is the vector, this is the direction of your line. So therefore, this is also your V. So therefore, we can say that this is your A, this is your B, and this is your C for your line. So we know that your line, or for the symmetric equations, we have x minus x sub 0 over A is equal to y minus y sub 0 over B is equal to z minus z sub 0 is equal to c. Therefore, we can substitute this initial points, which is this, and also this a, b, and c. So we have x minus 1 over a, so 5 is equal to y minus 0. Okay, I will just delete this 0. So y over b, which is negative 2, and then z minus 0, right? So we can just delete the 0, and then over c, which is negative 3. So this will be your symmetric equations. Okay, so that will be all for this problem. Let's see, do we have another one? Okay, for distances between a plane and another point, we can solve this one using this formula. So I won't show the proof anymore. It is pretty exhaustive, but maybe I can show this during class. But basically, you have this vector or the orthogonal vector n, we have this orthogonal vector n, this one, which represents this A, B, and C, as the elements of this vector. So remember this. And then this P1 is represented by the point x1, y1, and c1. And then for your plane, so we can represent this plane, you can remember, with A times x plus by plus cz plus d is equal to 0. So remember these three things, no? In addition to this formula, so that you can use the formula, you know. So you want to find orthogonal vector n and the given point p, and then simplify the equation of a plane into this form so that you can use this formula. So basically, this is just the direct substitution. You substitute x, y, and z, and then a, b, and c, and d. So that is how simple it is. So it should be an orthogonal, no? The point should be orthogonal to this vector to find the distance. Because if you can see, no, actually you can have a different distance here at a different angle, no? But it should be orthogonal for consistency lang, no? In this formula. So we have a problem here. So find the distance between these parallel planes. We have 10x plus 2y minus 2 is equal to 5, and 5x plus y minus z is equal to 1. Okay, so we assume that this is parallel planes, but how do we really know if they are parallel? No, we have given two parallel equations of a plane. How do we know if they are parallel? No, we can actually know this by inspection only. So if you can remember, we have the formula. We have ax, no, ax plus by plus cz plus d is equal to 0. We can find a, b, c, which is your orthogonal vector. Okay, so if you look at this a, b, and c here, they're actually in ratio, no, in ratio with, sorry, let's make this a little better, no. So this is in ratio, this is a ratio of 2 is to 1, and also for this one, okay, so we have 1 here, 2 is to 1, and then negative 2 is to negative 1. So if the ratio between this respective points or the respective elements of the vectors n, then it is parallel. Ano? So 2 to 10 to 2, or sorry, 10 to 2 is 2, no? Is 2, we have 5, 1, and negative 1 by the ratio of 2 is to 1. So if we have this ratio, this consistent ratio, then they are parallel. So it could be any ratio, ano? It is not limited to 2 is to 1. It could be 1 is to 3, 1 is to 1.5, and so on. So now how do we find the distance between these two parallel planes? So let's say we imagine this as these two planes. So these planes are parallel. So they are just on top of each other. Ano? And actually we should draw the we should draw the coordinate system. Okay, so let's say this is your first plane. So first plane, I think I will screw this a little bit. Let's say this is your first plane, and then we have a second plane here that is parallel to this plane. Ayan. Okay, so this plane are parallel now, as you can see here. And we want to find the distance. So let's say this is your distance between this plane. Okay, so you can imagine that this is the plane, and then we have a distance between these two planes. And how do we find this distance? So we know that this should be orthogonal to each other, no? This planes. So we want to find orthogonal vector of this planes. So we know that when they are parallel, their orthogonal vectors are actually equal. Okay, so what are their orthogonal vectors, or what is the orthogonal vector of this plane? Okay, so we know that this is this, no? So we have ABC, so we have we just choose this simpler form. So we have 5, 1, and negative 1. as your orthogonal plane or orthogonal vector. And then again, to find the distance, how do we find the distance? We already have the vector. We have to have an initial point pala, ano? So how do we choose an initial point? So it could be any point. No, actually, it could be any point. You can choose any point here. So for this case, I will just choose a point when assume na lang natin, no? So usually we'll have an assumption. So any point here, no, it could be here, it could be here, so it could be any distance here. It will be the same for every reference point. So assume, let's say, we have y is equal to 0 and z is equal to 0. Just to find an initial point p sub 0, ano? So I will just utilize, I guess, this one, okay? So for this initial point, we have 5x plus y minus z is equal to 1. So cancel this y and z. So 5x is equal to 1. So therefore x is equal to 1/5. Diba? Okay. So we have this point here. Okay. And we have this orthogonal vector. Uh, Actually, it should be the other way around, ano? Sorry. If you choose this as your vector, nga pala, you should choose this as your point. So, anyways, it might still yield the same answer, ano? But anyways, so we have 10x plus 2y minus 2z is equal to 5. So this will be cancelled into 0. So 10x is equal to 5. Therefore, x is equal to 1/2. It will not yield the same answer pala, no? So if you use this as your orthogonal vector, you should use this as your other point. Remember that, ano? So therefore, to find the distance d, this is the absolute value of ex1 plus b, y1 plus c, z1 plus d over the square root of a squared plus b squared plus c squared. Ayan. Okay, so we have already given, no, a, b, and c, and then y, x1, and x sub c. So we know that we have 0, 0, and 1/2. This is your x1, this is your y2, y1 pa siya, and then this is your c1. So how about the d? How about the d? Okay, so one thing we should do here to find this equation of a plane. So since we choose this as our orthogonal vector, so this will be your orthogonal vector, no? We want to find this equation of this plane. So we want to provide, okay, we want to provide here, um, no. Actually, this is D, ano? If you simplify this. Okay, so this is your D. So the equation of this bottom, which is this, so D is actually already given. I'm sorry about that. So D is equal to 1, actually, no? So the distance, big letter D pala, no? For distance. So this will be equal to, we have A, so A is equal to 5, x1 is 0, plus B, which is 1, y1 is 0, plus 1, D is -1 pala, no? So if we transpose this other side, D will be equal to -1. So -1, sorry, C pa pala, no? So C is -1 times, so C1 is 1/2, and then plus D, so D is -1, so minus D, and then absolute value over the square root of A squared plus B squared plus C squared. So A here is 5, and then 1, and then -1. So simplifying this will be 0, 0. So we have -1/2 minus 1, and then over the square root of, so this will be square root of 25 plus 1 plus 1. So this is the square root of 27. So this will be 3 halves, and the absolute value of this, no? So negative 3 halves, absolute value is positive 3 halves. So this will be 3 halves over. So what is the square root of 27? So square root of 27, we have the square root of 3 times 3 times 3, right? So 3 times 3 times 3 is 27. So we can factor out this 3 here. So this will be 3 times the square root of 3. We can cancel out the 3 here. So the final answer should be 1 over 2 times the square root of 3. Or if you want to, no, you can rationalize this. So this will be square root of 3 over 2 times 3. So 2 times 3 is 6. So we have square root of 3 over 6. Okay, so that will be all for this question. And then for, I hope this is the last problem, no? So show that the lines L1 and L2 with parametric equations are skew lines, that is, they do not intersect and are not parallel, therefore do not lie in the same plane. Okay, so we have two parametric equations of these two lines, and we want to find if this is skew lines. So if it is skewed, or if it is a skew lines or a pair of skew lines, then they do not intersect and they are not parallel. So how do we identify if they are parallel or not? Okay, so what can we extract from this information? For L1, if you can remember, no, we have x is equal to x sub 0 plus 80, and then and so on and so y sub 0 plus we have dt, and then we have z sub 0 plus ct. So we can see here that a, b, and c here are what? No? So these are the vectors of this line. Diba? So we know that the vector, no, so this, since this is a line, we will write this as vector v. So the vector of this line 1 is equal to the coefficient of this t. So we have here 1 and 3 and negative 1. And then for the vector of the line 2, so that will be the same, ano? This is just a different variable, but it conveys the same meaning. So this will be equal to, so 2, and then we have 1, and then this is 4. So how do we find if they are parallel or not? No? So if we compare their ratio, so we have 1 over 2, so 1 half. So this is 3 over 1. So since this is 3, so this is not the same. So they are, no, ratio niya ay inconsistent. Therefore, they are parallel or not parallel. Okay, so we already resolved the not parallel. We want to now find the intersections, if they have an intersection or not. So to find the intersection of two lines, so you can imagine, let's say you have two lines here. So if they have an intersection, then their point of intersection should be equal to each other. So therefore, we could equate this to x's. So we have x is equal to x. Okay? And that will be true also for y and then z. So therefore, this will be an equation wherein we want to equate this 1 plus t and 2s. So we have 1 plus t is equal to 2s. And then also for this one, so negative 2 plus 3t is equal to 3 plus s. And then this one, so 4 minus t is equal to negative 3 plus 4s. Okay, so if this equation has a consistent unique solution, then therefore it has an intersection. And how do we find if they have a unique intersection, or if they have a unique solution? Since we have three equations, we have only two variables. We want to try checking first for the solution of these two equations to unknowns. So in your linear algebra, you have to find the two equations to unknowns, no? Diba? So therefore, this will be, we will compare these two. So how do we solve for this? We will have two equations to unknowns. So we have 1 plus, I guess, to make things consistent, no? So I will transfer everything to the left, all of the variables to the left, and then to the right are the constants. So we have t minus 2s is equal to negative 1. And then also for this one, okay? And then exchange the constants, no? So we have 3t minus s is equal to, so we have 3, and then this will become positive, so 3 plus 2, so this will be 5. So to solve for this system of linear equation, uh, You can do a variety of things, but the fastest way to do this, if this is just a 2 by 2 matrix, no, we can just multiply, let's say this one by 2. Okay, so why did I multiply this by 2? So that I can cancel this s, ano? So multiply this by 2 and then subtract these two equations. So we have here negative t minus 3t, sorry, t minus 2 times 3t. So this will be t minus 6t, right? So this will be negative 5t. And then for this one, so 2 times s, so negative 2s. So negative 2 minus negative 2s, or negative 2s minus negative 2s. So this two will just cancel out. So this will be just 0, and then equals to, so 2 times 5, and then negative 1 minus, so this is 10. So negative 1 minus 10 is negative 11. So the solution here, what's the solution here? Did I got it wrong? This should be, oh, hmm. Oh, this should be 2, right? Huh? I think I got this wrong. This should be negative 2 positive. Huh? Did I got things wrong? Hmm. Okay, it is actually correct. Oh, sige, negative 11. Okay, negative 11. So we have t, negative 5t. So go to negative 11. Therefore, we can say, no, so divide this by negative 5. So t is equal to negative 11 over 5, right? Oh, sorry, it should be positive since the sign will cancel out. And then for s, so for s here, we can just substitute any of these two equations, the value of t. So I'll just substitute this here. So for the second equation, we have 3 times 11 over 5 minus s is equal to 5. So we have 3 uh 33 over 5 minus s equal to 5. So this will be transposing this to the other side, s to the other side. So this will be minus 5 is equal to s. Okay, so s here will be equal to, I'll just shortcut here now. This will be equal to 8 over 5. Okay, so how do we know if this is consistent? So we already know the solution of this. If we substitute this t and s here, if this is equal, then therefore this is consistent. Therefore, we have an intersection. So let's substitute the value of t and s here. So we have 4 minus 11 over 5 is equal to, okay, so for this one, and the value of s here. So negative 3 plus 4 times 8 over 3. 8, sorry, 8 over 5. 8 over 5. So we have here, we have 20 over 5 minus 11, right? And then we have negative 15 over 5 plus 4 times 8. Okay, so this will be 9 over 5. This will be, so 4 times 8 is 32. So 32. So negative 15. So we can see already that this is not equal, no? So 15, this will be, so 12, so 17. So 17 over 5. So we can see that this is not consistent with our solution. Then therefore, we could say that this is not parallel. sorry, not they do not have an intersection. So therefore, no intersection. So if they have no intersection and they are not parallel, then therefore L1 and L2 are skew lines. So what does this mean, no? So if we draw this, let's just imagine, let's say this is the line, and then this is another line in the three-dimensional space, wherein it's hard to really draw something here in two dimension that you try to convey. So you can imagine in the 3D space that they are not parallel, so they do not have the same slope, and they do not have an intersection. No? So in three dimension, it is hard to really imagine this, no, in a drawing. But you get the point. Okay, so if the given lines are skew, find the distance between them. Okay, so how do we now figure out this problem? So if you have two given lines that are skew lines, okay, so let's say this is your line 1, and let's say this is your line 2, okay, this line 2, okay, what we can find is this distance in between them when we make one of these lines as a plane. So we can derive a plane or a coplanar line in this. You can imagine, let's say this is your coplanar line that represents this plane. Okay? So what we want to find here is to find this distance. If you can recall, we want to find, yeah, let's write this here. So we want to find the orthogonal vector ABC and an initial point x1, y1, and z1, and also the equation of this plane. Okay, so this will be your distance. So for the orthogonal vector, no, between these two, this is actually your orthogonal vector. This red line here, this orthogonal vector will be your, let's say this is your line 2. So we can create an equation of a line using this one. And how do we find this one? How do we find this orthogonal vector? Okay, so if we actually observe this direction, no, so let's say this is your direction of your line 2. So let's make things consistent here. And this is the direction of your line 1. Then we can find an orthogonal vector. Okay, okay. We can find an orthogonal vector that is the cross product of these two vectors. No? So the cross product of these two vectors, so orthogonal to this, orthogonal to that, will be the cross product of V1 and V2. Okay? So we already have a solution for this vector. So we want to find the vector 1, vector 2, and then find the cross product, we will find the orthogonal vector. So how do we find the equation of a plane? So for the equation of a plane, we can choose any point in this plane or in this line, to be specific, no, any point here, and then substitute that value to get the equation of a plane. And then another thing, to find this point, no, so we want to find this. So for this one, we want to find this any arbitrary p sub 0, no, for the plane. So for the reference point at the end of this vector, we want to also define this x1, y1, and z1. Okay. So let's do this. So to find v1, how do we find v1? Actually, we already defined v1, no, last time. So v1 is already here, and v2 is already here. So let's just write this down. Okay, so v1 from the previous problem, that is equal to the coefficients of the t. Okay. So we have here 1, and then 3, and then -1. So for V2, that will be the same. We have 2, 1, and 4. Okay. And then for the cross product of these two vectors, this is equal to, how do we find the cross product? So the determinant. So we have ijk, therefore this is 1, 3, -1, 2, 1, 4. Okay. And then duplicate this first two columns, j, 3, and 1. Yeah. So to find this cross product, so multiply this for I. So we have 12i minus this one. So minus -2i. Okay. Is that right? Why is it wrong here? 131. So why is it 13? Should be 14, right? Oh, it should be only this. No? Sorry, it should be -1 or -i. Okay. And then plus we have j. So this is -2j minus where is it? This one. So 4j, and then plus, so for the k, I'm sorry, this one, this is the k first. So plus k hat minus 6k. So simplifying this, we have 13i, and then we have plus, actually this will be negative 6j, and then -5k. So this will be your cross product, or again, we have this orthogonal vector, and so we know that this is your A, this is your B, and this is your C of this orthogonal plane. Now, to find this D, so we want to find first the D, we can substitute the value of any point in this line 2. So since we chose this line 2 as our arbitrary plane, then we can substitute this 2s plus 3 plus s and then -3 plus 4s. So the n vector, sorry, the equation of a plane, which is a times x minus x sub 0 plus b times y minus y sub 0 plus c z minus z sub 0 plus d, sorry, is equal to 0, can be defined. Although we do not have yet a value of x sub 0, y sub 0, and z sub 0. So how do we do that? Okay, so we have a given here, this parametric equation. We can choose any value of s, no, to just define this arbitrary point x sub 0 to z sub 0. So let's just say now, to make things simpler, so let's just say, again, s could be any value. So let's just choose s is equal to 0. So if s is equal to 0, then x is equal to 0, y is equal to 3, okay, and then -3 plus 0, so z is equal to -3. Okay, so this is your reference point, 0, 3, and -3. Now, to solve for this, no, so since we have already this given, we can solve for d. So we have a, b, and c. So we have 13, -6, and -5. So we have 13, -6, and -5 is equal to 0. So we have x minus x sub 0, so 0, y minus 3, and then we have c minus -3. So this will become positive, and then simplify. So simplify this. So the variables first, so 13x, and then -16, 6y minus 5z, and then the constant, so -6 minus 3, so plus 18, -5 plus 3, so -18 is equal to 0. So simplifying this, we have the equation of a plane, okay, that represents this, no? This one is this equation. So we can simplify this as plus 3 is equal to 0. So therefore, we have a value for D. So D is equal to 3. Okay, we already have a value for D. So okay, good. We have value for A, B, C, and D. We now want to find x1, y1, and z1. So for x1, y1, and z1, so any point at the first line, we have this. So any arbitrary point here, guys. Now, you can choose any value of t. So any value of t. So let's just choose t is equal to 0 to make things simpler. No? So if t is equal to 0, then x is equal to 1. Okay, same goes for y. So -2. And then z is equal to 4. So therefore, we have this P1. The P1 here is 1, -2, and 4. So this will be your x1, x2, y1, and z1. Therefore, again, we could solve this now, this distance, which is the absolute value of ax1. So a is equal to 13, x1 is equal to 1, so 13x1 minus 6, and then y1, so -2, and then -5, and then 4, and then b is 3, so plus 3, absolute value of that, over the square root of 13 squared plus 6 squared plus, sorry, it should be negative now. And then, anyways, it will become positive, minus -5 squared. Okay, so what is this? We have 13 plus 12 minus 20 plus 3. So this is 25. Minus 20, this will be 5 plus 3. So this will be 8. So 8. And then all over. So this one is, so this is square root of 169 plus 36 plus 25. So this one is 175 plus 30. So 205 plus 25, that will be 230. So square root of 230. Okay, should we simplify this? Okay na yan. This should be good enough. If you can simplify this, then you can simplify this further, but I think this will be okay for the distance. Okay, is that all? Okay, so that is all. So thank you guys for listening. I hope this will be a comprehensive. I already gave a comprehensive example. So good luck and see you in class.